Alright, so in this video we're going to take a look at the compound angle proofs, and we're going to start with the very first one, which is cos A minus B. So this proof starts by drawing out the unit circle, and what we know about the unit circle is that the radius of the unit circle is 1 unit in length, and that any point on the unit circle could be described in terms of a rotation about the unit circle. So let's take a look at what that means. So if I put a point here, and I'm going to call it the point P, that is a distance of 1 unit away from the origin. So it is exactly 1 unit in length. That point P there could be described as a rotation. It could be described in terms of the rotation around the unit circle. So how far did I rotate around? So what we would need to do to be able to write that is we would first have to mark in an angle there, A. So I'm going to mark it in a bit bigger so we can see it nice and clearly. So that there would be our angle of rotation, A. So if that's the angle of rotation, then this point here, P, could be described, instead of describing in terms of the x and y coordinates, we could describe it in terms of cos of the angle A and sine of the angle A. And if you're unsure about that, go back to your polar form, think about your periodic functions, have a look at those notes, and it'll start to make a bit more sense. If I had another point then over here, let's call it the point Q. So I'm going to call it the point Q. And I'm going to say, well, that distance out here, again, it's the radius, and we know that the unit circle has a radius of 1 unit. So that is going to be 1. And if it is rotated around, I've used A, so I've rotated that around an angle of B now. So that means that the coordinates of that point could be described in terms of the rotation of the angle of an angle of B. So I'm going to have cos of B, sine of B. So this is what we have, and we're looking to show cos of the angle A minus B. So where would the angle A minus B actually exist? Where would we find that? Well, that is going to be the angle A, and the angle A minus B would be that angle inside here, because that's the angle A is the full way around. That's the angle B. If I take that away, I'm left with what was in between. So this is the angle A minus B inside here. Now, we're looking to figure out what cos of that angle is. So to be able to deal with cos, I'm going to need a triangle. So I'm going to connect this line up here between P and Q. And I'm going to make this a bit clearer for us here. So let's just tidy this up so that we can see where things are coming from. So that yellow angle inside here, that is A minus B. Okay, now what I would do for myself is draw that triangle out over here. So I've got this distance here from P to Q. It's a little bit slanted like that. Then I have this line here, which we actually know what that is. We'll come back to that in a moment. And we've got this line up here, and we also know that distance. So that distance from there to there is going to be a distance of 1, because this would be our origin here. This distance from here to here would be a distance of 1. We don't know what that one is just yet, but we do know that we're labeling this angle in here A minus B. So looking at the diagram, we can see why that is A minus B, because it's the angle A if we were to take away the B part. So it's the angle A minus B. So that's what we're dealing with inside here, this angle. Okay, so there we have our triangle starting to come together. We then know that this was the point P over here. We said that that point could be described in terms of cos of the angle. So that point there is cos A sine A. And we said that this point over here was going to be cos B sine B. So cos of B sine of B. Now, we're looking to figure out cos of A minus B. So what kind of formula brings cos of that angle in? Now, it's a non-right angle triangle as far as we know at the moment. So we're starting to think about, could we use things like the sine rule or the cosine rule? And because I have two sides and I have an angle, I would go with the cosine rule. So we're going to use next the cosine rule, which says that a squared is equal to b squared plus c squared minus 2bc cos of a. Now, in that, what we know is that the side A has to be opposite the angle we're going to use. So this here has to be our angle and our side. So that's going to be the angle, and the yellow side is going to be our side A. The sides B and C don't really matter which one is which. It's the A that matters the most. So B is going to be, let's just say, the pink side, and then the blue side, let's give that to C. So what we do then is we're going to fill that in. Now we don't have a value for A, but we do know that it was between the points P and Q. So a nice way of writing that might be the side length PQ. So P to Q, and then using the side length of P and Q is what we're using. So that's going to be PQ squared is equal to B squared. Now we know that B is going to be 1, and that is because it's part of the unit circle. So we've got 1 squared plus C. Now C was going to be this side here, which was 1 as well. That's going to be then multiplied, or sorry, take away 2 multiplied by B. So 2 multiplied by 1 multiplied by C, which is 1. And then cos of the angle A. Now our angle A in this instance is going to be A minus B. So this is what we have. So that all I've done there is filled into the formula for the cosine rule using that triangle. So this is what we have. Now, tidying that up a little bit more for ourselves, we're going to have PQ squared. That's actually not going to change at all, so I'm just going to copy and paste that down. There's no change with that. But we will have a change here. 1 squared plus 1 squared, that's going to give us 2. So I'm going to write that as 2. And then we're going to have minus 2 by 1 by 1. Well, that's going to be minus 2 multiplied by cos of A minus B. So multiply that by cos of A minus B. So that is it in its simplest form. Now, we're looking to get down to show that cos A minus B is equal to, remember, cos A cos B plus sine A sine B. So we're going to need to figure out a way of getting rid of the 2's and also that PQ squared. So let's take a look at what PQ squared might link us to. So if we look at PQ, it's the distance from here. Is there any other way I could figure out that distance other than using the cosine rule? Well, actually, we have a formula for the distance between 2 points that we could use. So that's what I'm going to think about now. So the distance between 2 points is given by a formula in the log tables, and it is the square root of x2 minus x1 squared plus y2 minus y1 squared. And what this formula is going to allow me to find is it's going to allow me to figure out what PQ is and replace it up here. Now, x2 and x1, those are coordinate points. Do I have coordinate points? I do. I've got them in terms of cos and sine, and that's perfectly fine. So what I'm going to do is label them for myself. So this is going to be x1, y1. This is going to be x2, y2. So this is what we have. Now, filling that into the formula, I've said that x2 was cos of b. So I'm going to just copy the formula down, and I'm going to replace things bit by bit with what we've said that they are. So I've got PQ is equal to the square root of this. So I'm going to start replacing things. We said x2 was cos of b. So let me write that in. So I'm going to have cos of b minus x1, which we've said was cos of a. So cos a. And then it's going to be plus y2, which was sine b. So y2, which was sine b, minus y1, which was sine a. So all I've done here is replace the x and y values in the formula with what we've said they were, and we said they could be described as the rotation around the unit circle. So that's what we have. Now, I don't really like dealing with the square root, so I'm going to get rid of the square root, and how I undo a square root is by squaring both sides. So I'm going to undo that by squaring both sides, and what I get then is that pq squared is equal to all of this. Now what we would do next is we will keep the left hand side the same. I don't want to change anything about that. I'm going to now square out these. So when I square out cos b minus cos a, what I'm going to get is I'm going to have cos b all squared. Then it's going to be twice the product. So twice the product is going to be a negative, so minus 2. And then the product means multiply. So it's going to be 2 cos b cos a. So 2 cos b cos a. And then I'm going to have the cos a squared. So then I'm going to have plus cos a all squared. So all I've done there to recap is I've just squared out the first bracket here that we had cos b minus cos a. I've squared that out and this is what we got. Then I'm going to get the same thing when I square this out, but in terms of sign. So we're going to have sine of b all squared. So sine of b all squared minus twice the product, so minus 2 sine b sine a, so I'm going to fill that in. So sine of b sine of a, and then we're going to have plus sine a all squared. Now, what I can do in this instance is I can group the cos b's and the sine b squareds. I'm going to put those together and we'll see why in a moment. So what I'm going to do is I'm going to have cos b all squared. Another way of writing that is actually cos squared b. Just a shorter way of writing it. Instead of writing the brackets and all squared, I can write it as cos squared b. And then I'm going to have with that sine squared b. So I've just put those two together. Then I'm going to do the a's next. So I'm going to have plus cos, and again, squared a is what that becomes, plus sine squared a. And then I'm going to bring down the rest of it. So I'm going to have my minus 2 cos b cos a. So I'm going to have that. And I'm also going to have minus 2 sine b sine a. So I'm going to bring that down. Now, there is a rule that deals with cos squared of an angle and sine squared of an angle. And that is, the rule that we're using is that if we have cos squared of an angle plus sine squared of an angle, that is the equivalent of having 1. So every time that I have a cos squared of an angle and sine squared of the same angle, I can replace that with 1. And that's exactly what I'm going to do with these guys. So that becomes 1 and that becomes 1. So I'm going to move this out to the side here. But that's what we're using. It's in the log tables, you don't need to remember it. So it becomes 1 plus 1 minus 2, and then it's going to be cos b cos a sine b sine a. So I'm going to bring that down and copy and paste just to speed things up for us. So this is what we have. Now, all of that was equal to pq squared. So the length of pq squared. I can tidy it up further. I can say that 1 plus 1 becomes 2. So I can even write that a bit neater for myself and write that as 2. So that's what we have. Now, I already said that pq squared was equal to something else. We said that pq squared was equal to 2 minus 2 cos a minus b. So we've already identified what pq squared was. So I can actually replace it with 2 minus 2 cos a minus b. So instead of writing this, I'm now going to write what we said it was earlier. So I've said that it was this. in the first half of the calculations. So I've just replaced PQ squared with what we said it was earlier. And that's going to be equal to then 2 minus 2 cos B cos A. So let's see what we can do with this then. So first thing I could do here is I could say subtract 2. So subtract 2 from both sides. And what that's going to do is get rid of this 2 and this 2. They both go to 0. The next thing, what I'll be left with when I've done that then is minus 2 cos of A minus B. So minus 2 cos of A minus B, that's going to be equal to minus 2 cos B cos A. So I'm going to be left with this part. Now, we're really close to the end here. What I need to do next is I need to get rid of that minus 2, and it's the whole way across. So what I'm going to do then is I'm going to say divide by minus 2. And what will happen is this will go to 1, that will go to 1, and that will go to 1. And they'll all become positive. So I'm left then with cos A minus B. So cos of A minus B, that's equal to cos B cos A. So cos B cos A, which is the same thing because multiplication is commutative. It's the same forwards and backwards. It doesn't matter whether you say cos B by cos A or cos A by cos B. It's the same thing as having this. And then we're going to have plus, and it's going to be sine B. So sine B, sine of A, which is the same thing again as having sine A by sine of B. So it's the same thing. And that should be, at this point, what they asked us to show at the very beginning. So let's take a look. Does cos A minus B, is this the proof that we were aiming for? So we said that is equal to cos A cos B plus sine A sine B. Right back up to the top, what were we asked to prove? Cos A minus B is the same thing as cos A cos B plus sine A sine B. So there we have the first compound angle formula proof.